Hey, good morning, good afternoon, everyone. I hope everyone at your end, including you, are safe. So, on behalf of All India Orchid Group, I would like to welcome you today for our weekly webinar session. Today, we are lucky to have Robert with us, who will share his insights on 10 reasons to choose Apache Pulsar or Apache Kafka for event sourcing. So, Robert actually designs and develops application integration solutions both on premises and in the cloud. Besides application integration development, he's also advocate on blockchain IoT microservices. I'm sure he will share his books in his presentation. So Robert is heavily involved in development community. He's an international speaker, presented in Oracle Open World, Code One, and many other conferences. And he's also Oracle Ace and Groundbreaker Ambassador. So warm welcome, Robert. Before handing over to Robert, I would like to remind you a few things. Um, from this webinar onwards, we basically stopped streaming all social media channels because we want to give more preference to the registered participants. So going forward, it is going to be a Zoom webinar channel only. So the presentation will be shared with all registered participants. You need to do one small thing. You need to fill the survey and get presentation access. So we will send you the email after this webinar. Please check your mailbox, and it takes only 2 minutes. Provide a feedback so that we understand your demand. So at the end of the session, we will also run online quiz. So looking forward to who is going to win this today's quiz. So for all your questions, please post it in the Q&A section so that it's very easy to answer for speakers. Also, you can take, so Robert is on video now, so you can take a selfie with him and, thank Robert using his Twitter email ID. I'll share with after some time after his presentation. So with that, I'm handing over to Robert. Thank you.
Yeah, thank you very much for this introduction, this nice introduction. Thanks everybody for joining in this afternoon for you. For me, it's still nice in the morning, nice and sunny here. So hopefully also good lighting. Let's go to my presentation, right? Can I share my screen? Easy. You want to continue? Yes. Share my screen. Share this one. This one. Hopefully my screen is joining. Yeah. Okay. Hopefully everybody can see my my screen and presentation. Yeah. So yes. Today, the topic of today is. I go over 10 reasons to choose Apache Pulsar over Apache Kafka, and specifically on the topic for event sourcing and also CQRS. So yeah, I've already been introduced. My name is Robert Vermolken. I'm a solution architect and developer, mostly on integrations, so on-premise and in the cloud. Besides that, the topics I do business development on are usually on blockchain and IoT. And I wrote till now 2 books, one on integration cloud in 2016, 2017, and one on blockchain, which was published end of 2018. Both use Oracle for the implementation, but for blockchain, it's also very the common principles and what it means and what you can use it for, how you design a blockchain. So yeah, you can check them both out on Amazon and also on Packt. If you want to follow me, you can check out my LinkedIn or Twitter. Preferable Twitter, of course. That's where I post the most things. So I have some topics to cover today. I want to first explain a little bit what event sourcing is, and also what CQRS means. Then we'll look at what the common problems with Kafka-based projects is, if you want to not only do event sourcing, but what common things are where you, if you use Kafka, where you need to put some effort in. Then I will go over to Pulsar and introduce a little bit of what's Pulsar, where it's a little bit different than Kafka. And also after that, we'll go to some reasons to pick this. And if there's time, we have around an hour. If I have time, then I also want to show you a little bit of getting started. I made get it started on Oracle Cloud Infrastructure to be able to run Pulsar on a Kubernetes cluster. So if there's time, we go over that also. Get a little bit an idea. The hands-on and how you get started is already a little bit part of GitHub. So that will be updated in the upcoming time as I do this presentation more often. So let's go over what's event sourcing. In the meantime, if you have questions and stuff like that, just ask them in the Q&A. I sometimes look at my second screen. So if I look at the right for you, then I know that I am checking out some questions if they're there. So what is event sourcing? So event sourcing is in the picture, what you see is a kind of architecture. More, it's based on the event-driven architecture, where everything you do within a web app and your backend is based on events. So here in this case, we have a web application where both a laptop and a mobile phone or mobile device can use. And instead of calling an API to get a response or to publish or create things, the action that you do is generating an event which is published to a topic or a queue, and it's published once, but you have like many applications can be subscribed to this topic and process this event on its own way and react on it if they want with a different event. So it's it's an event-centric approach, and where you persist like the state of an object. What's the current state? Not so much as okay, this is the final answer, but so if you want to know the final result of a certain object, you need to go through all the events to build up the result. So this object or these events that's coming in are persistent stored in a sequence. So always you need to process the whole sequence. So when that state of object change, and if an event is generated, this event is always appended to the end of the sequence. So this means that every app that's connected to the topic will have sufficient information to reconstruct the state of the object. So then we also have the information of the so event sourcing. So just publish the events on the topic. Then a second concept is CQRS, which stands for Command and Query Responsibility Segregation. And what this means is that the writing is separated from the reading interface. So if you have a front end that changes an object state, it will generate an event. It will be placed on an event queue. And this event queue is also stored. So it's persisted, which That's why in this way you can replay, for example, the sequence of events, and using just a small background process, which is usually an event handler. It's also safe to, for example, the application state, which can be like a key value database or something like that holds eventually all the events and also the end state, because the read interface uses that application state to query the information, right? So the event is the command which comes in, but the query is segregated from each other in this system. So in this case, the processing of the commands doesn't interfere with querying of the data for the application. So it's separated. So the bits of the system that are responsible for changing the state are physically separated from the one that manages the views on the application. And if you looked at it in contrast with a traditional CRUD architecture, so a relational database with a CRUD service on top of it, for example, then it's both that same component. If it's an API or it's a PLSQL package or something like that, it handles both responsibilities. If there are any questions, just put them in the Q&A, then I can check that. See a raised hand, so just add them in the Q&A. So why do we use event sourcing and CQRS then, right? So there's a few things with CQRS that makes it useful. It's in this way it's very scalable. So you can have multiple event stores, multiple subscribers, and multiple readers. Because it's separated, right? The read state is separated from the write state. So in this way, you can scale things up. You have performance that you can control. You make it simple, more simplified. What it just means is that the writing model, so writing a command and reading data can be different, right? Events change the state of an object. So there can be multiple types of events, of course, that at the end can manipulate the same state. It gives you some flexibility, and because you know that there's clear separation, and you can change, for example, the commands without needing to change, for example, the view. And you can also define multiple views, of course, on that same application state of that object. And what also is that you can be a little bit more business focused. So you can create applications that are more responsive to change, right? And also cheaper to maintain those things because it's separate. So you can say it's a command or an event, and then and the queries are separated. So let's head then to the problem: why would we then not just use Kafka, right? It's already there for a long time. Maybe there's a big community. Maybe Kafka is already a known thing within your company that you work. Where Pulsar is, if you say Pulsar, what's Pulsar? I don't know what Pulsar is. Pulsar is already there for a long time. It was first, of course, internally. I think it was in. Need to check it in Wiki Yahoo. And but yeah, there's a reason why Pulsar is now getting more attention, and that's the reason why that it fixes some things Kafka does differently. So the main common problem that you see is scaling with Kafka. If you use Kafka in production, then Kafka works with here you see the nice picture with ships, with containers. If you think about having specific topics, specific a piece of software called the brokers, also the storage. The main thing is that if you want to scale with Kafka and you add like a new broker so you a peer or a new machine, right? You want to able to become part of the network and try to rebalance things. Then Kafka is based on distributed logs, and we go there over in a moment. Distributed logs. So if there's a new ship that you add to this, so a new host, then it needs to rebalance and copy the whole log over. And when you have like gigabytes of data, before you can like have this new host be able to process messages, it needs to be synchronized in full before it can be used. And Pulsar does this differently, and we see it in a moment in the reasons why. Is that Pulsar uses a distributed ledger, and when you scale something up, then immediately instead of copying over a whole log and before it can start, it copies over the most recent segments to process for anyone that wants to do that. And then the history it will come later to this. It will be synced later. So if you want to scale, it's immediately. You can immediately use the new host and the new the new resource. Oh, no. See that we're a little bit missing. So let's stop the animation. So a little bit, maybe too much information now on screen. But, so with scaling, with Kafka, it's a little bit more difficult. And this is because the broker is a stateless broker. This means that the broker stores data within Kafka, Kafka stores this data within a broker. And if you want to dispute logs, that means that the broker will be busy copying over the distributed log to a new broker, which means it can't do anything else, or it can't do the processing of new events, maybe a little bit slower. With Kafka also is that changing the size of a partition. I don't know if you know, but Kafka uses, you can say, okay, I make a partition of data or topics that I could put on a partition. And because it uses the storage on the broker, and you change things, the sizes, and it still processes messages, and it needs to change the size. You can get brokers that use a different order, message order. They are processed later, and so if you ask data current state from like one broker, it can be different than from another broker. And with CQRS, we don't really want that. Even the commands and also the queries are separate, so you don't want to have different results, right, on the different application. One thing is with this is that to be able not to have this problem, you need to plan and calculate the number of brokers that you think you might use in the future. So if you think, now I have like, we have a customer, now we have like 70 million messages per year. But in the future, we go to 1 billion messages a year. Then with Kafka, you need to already plan in the amount of brokers and partitions and things like that to handle the 1 billion messages, not the 70 million, because then you will get this problem. If I need to copy over 70 million messages to be able to have a new broker, it's gonna take a little bit of time, and maybe the problem arises of the message order. Yeah, I already said it impacts the performance for the connected producers and consumers. because of the synchronization. Now, other things that are like more interesting is also a little bit of the development side. So there's no native authorization on any events or commands that you put in on Kafka. They have a message validation side, but they don't have like a policy who can read and who can write from a certain topic. And if anybody knows the concepts about smart contracts and blockchain, it is a light version of blockchain, Pulsar. But this understanding that it's not there. But the other thing is, if you want to really do things with Kafka and event stream that's coming in, if you want to analyze it, if you want to do stream processing, you need to have a different tool. You need to install something separate from Kafka. It can be Apache Spark or Apache Heron, or that can be Kafka Streams. But you need something there. It's not part of Kafka by default. And the last one here is you can't do geo replication. You can do that, but it's not native. Also, or in the latest version they added, but because of the copying of the data and the delays of the delivery between the two things, we've seen things like that we lose data. Or that it's delivered later than others, where you can still get, again, the query of the data will be different in one continent or one place to another place. So let's switch over to Pulsar. So Pulsar is also an Apache project. It's also open source. So you can look at what they are doing and contribute if you want. Say same thing as Kafka. But what is Pulsar if you compare it to Kafka? So Pulsar uses the same concept from Kafka, so the high performance streaming of events, because Kafka is really good in that. So if you don't have like the replication, you don't have like the big events data and things like that, you won't notice problems with Kafka. Kafka is very good. And you can still do things like, we will see some differences later, but you can do things in Kafka that already makes that a good product. But there are just things that you say, okay, but with Pulsar, I have the high performance streaming, and I also have like the traditional queuing. So Kafka only does event streaming with topics. And with Pulsar, I can also do traditional queuing mechanisms. So I can set up policies. I can set up who can read. I can set up failovers. I can do I can attach like a message model, how things can be processed. We'll see some things in a moment. So Pulsar gives us one system for both streaming and queuing, but with the same high performance that we see on Kafka. And if you use topics or you use queues, it doesn't matter, it's the same API. So here are some things that what Pulsar aims to and what provide, and we go over them and some in them in more detail, because here are starts the interesting things is that so data is automatically replicated and synced to disk. So this is there because the information that's coming in the broker it's separate from the storage. Pulsar supports multi-tenancy, so that's something that Kafka doesn't support. And with multi-tenancy means that within one cluster you can have multiple use cases, multiple tenants, multiple, for example, you can make a tenant per application. If we have time for the demo, I show you, I've made a tenant for the user group where you can have tenants. Every user group can be a tenant in my cluster. One interesting thing, they have the concept of tiered storage, which means is that you can have I see some questions also. Maybe go to them first. Can we use Pulsar as an ingestion data for IoT? Yes, you can. Pulsar has the concept of also have the Kafka API that you can use, but yes, you can use it ingestion for data. It's like it's the same. It's for streaming data for that like that. Is Kafka Streams not part of Apache Kafka? I think it's it's something you need. If you install Kafka, you need to, I think, install it separately, right? Correct me if I'm wrong. How the data is secured when the data is in motion. So this is an interesting thing. Pulsar has end-to-end encryption. So that's a nice one. You have like also TLS, SSL, all those things. What do you mean by tenant? A tenant is an organization. So if you have multiple organizations that you work with, a tenant is also with a distributed network. It's a peer in the network. It's an organization. It's like if I have, for example, insurance use case, then you have the insurer, but you also have maybe, for example, in the Netherlands, I have a lease car, so I also have the lease company, which can then also be a tenant in this. So, but it can also be a department in your company. Teams different clients. Is tenant means different client? A tenant can have multiple clients. But let's say this tenant, it can be a department organization. Okay, we have them. Oh, good. So what was it? Tier storage. So hot and warm data. So if you look at IoT, you have warm, a hot path, and you have a cold path. So you have hot data and you have cold data. Hot data is for real-time access. So if an event comes in, a consumer directly reads it, or you process it with maybe with a little bit of business logic. And a cold event, it's something we store somewhere else, like for later, which makes like cold events makes a little bit cheaper if you store it like that. Is Gate support for Apache Pulsar? What you can do is you can create functions. We go that over in a moment. And if you do a function, you can create it in Java and in Python. So with this, you can maybe make a connection, connect to themselves. I don't know if there is already a Golden Gate Pulsar connector, but there is a SDK to create connectors. Okay. So it's Pulsar supports geo-replication out of the box. So the cluster itself can be over multiple locations. They can be connected to each other. So you have like distributed applications. Like it's more like the concepts also behind blockchain, smart contracts. Because there you also have distributed applications, the apps. You can really do cluster expansion. So if you have like one cluster, you make it highly available, you can add a cluster, and it's you can add it without any downtime, because it doesn't copy over like immense kind of logs. Certainly if we have like the tiered storage and the cold storage, this makes it like also start very quickly, because the data is not stored in the broker itself. We'll go over that in a moment in more detail. So Pulsar functions. So what you can do is you can create functions. There's an SDK for that in Java and also Python, where you can make a little bit of a lightweight compute functions. It's like serverless functions. And with these functions, if you want to do that like on Kafka, yeah, you can do certain things with Kafka streams to manipulate the data, but real functions, that's something that Kafka doesn't have. The one that now is already mentioned a few times by me. So the last three things. So you have, let's see. Another question comes in. In Kafka, we need to run other components such as Zookeeper. In Pulsar, what are the different components need to run? We go over that in a moment. But Zookeeper is also part of Pulsar. Unfortunately, I have to leave. No problem. It's recorded, so you can watch it later, Jack. Okay. So other thing is that we have a message model, unified message model. So it supports both the topic and the queue mechanisms. The throughput is also very high, so it's not really different as Kafka. It can reach 1.8 million messages per second. I saw a blog of like the maintenance, the people that the enterprise part of Kafka now in the cloud, that it supports, I think, 10,000 gigabytes per second. I don't know how that reaches with million messages, but if you have a normal setup, this is like it can reach 1.8 million and within a single partition. So if you have multiple partitions, it's 1.8 million messages per partition. And it's highly scalable. It can support millions of topics, and also because of the functions, and it supports like a different message validation types. We go over them. It also makes it easy to model, to do data modeling. Okay. Let's go a little bit more in the detail of those. So the reasons why you pick Apache Pulsar for event sourcing, 10 reasons. I go in a few in more detail and some not so much, because so streaming and queuing come together. I already said it. So this is Kafka. Kafka is only an event streaming platform. So it implements the top concept of topics. So you have it's a pub sub system, right? It uses permanent storage. It can do it can process event streams then with Kafka streams, or using Spark or Heron. And it supports Avro message validation schema. So if you put a message on a topic, it can be validated using an Avro schema, so that you can't put in messages that are using this validation schema. It's based on distributed logging, and it has capacity of handling trillions of events a day. So if you then look at Pulsar, so Pulsar started as a message queuing platform, but then it had it has also is also able to have the high rate events like Kafka. So that's why it makes it, for me personally, like a sub. So you have Kafka, and then the next step might be using like Pulsar for if you have the extra functionality there. So it implements the concepts of the topics like the pub sub and the distributed and cold storage. We see there's a difference, which makes it really a plus for if you want to scale. It can do event processing with functions, and also within itself, and it allows multiple message validation schema. So not only Avro, but also JSON schema, and some more. We go over that in more detail. And also, if there's no schema, it does it in raw format. And besides that, it has a lot of queuing patterns. So you can do multiple consumers, and the one that's quicker, that picks up the message. You can do failover and subscriptions, and you can also send a message to multiple at once. And with Kafka I put an event on it, and if one consumer picks it up, it's picked up, it's read and stuff like that directly. So and it's based on distributed ledger and log segments, so not not a distributed commit log that need to be synced. So from this, let's pick out a few of them. And the first one is the logs versus the distributed ledger. So Kafka logs are append-only logs. They are sequential. So the data can be written and extracted from them very quickly. But Kafka are simple logs, and you get into trouble when they get very large. You need a lot of storage. You maybe need to scale if you want to scale up or scale out the brokers or anything, it can take time, it can get problems. And also with replication, right? If you want to extend the cluster, the one cluster, the first cluster is already busy helping to get the second cluster up and running. So this means that your production can have really performance issues because your cluster is not available to handle all the events. So for event sourcing and CQRS, it's important to distribute those events quickly and to all the consumers, even when the loads get high. And there's where Pulsar does it differently. So Pulsar avoids this problem by not copying the large logs, but breaking them into log segments. So it distributes those segments across the multiple servers while the data is written back to Bookkeeper as its storage layer. So you have the broker, which uses Zookeeper, and you have Bookkeeper for the storage layer. No questions till now. So this is how the architecture looks like a little bit. So you have a Zookeeper, which just has the metadata and also the coordination. I mean, with Bookkeeper. Bookkeeper is a tool from Apache Bookkeeper. Like Zookeeper is also, and it's one of the components used in Pulsar to do the storage. You have clients, producer, and consumers. They connect to brokers, and a broker has where you have then you see Pulsar. So Pulsar is the middle layer where you see the brokers, the topics, the partitions, those things. Then Zookeeper is for the metadata storage and the service coordination. So and Bookkeeper is the persistence layer. And Bookkeeper uses also streaming logs. So with the ledger and with segments like blocks in a blockchain, for example. You can have a Bookkeeper has one or multiple clients that handle that. It's what's called a bookie. And you can see here that some fragments that come in and persist are available maybe first on one bookie, and then maybe are synced later to another one. Or a bookie is specifically on a certain ledger, so it might not. It's maybe not part of maybe a certain topic or a certain interaction, so it doesn't store this segment. So that's the thing, is that instead of copying over the logs, Pulsar using the mechanism of copying over log segments. Yeah, the third reason and third plus is tiered storage. So for event sourcing, it's important to be able to also to replay messages that already be consumed. So for example, if a new consumer is there, it's added, then it wants to it needs to consume all the messages, replay all the things so it can have the same state. For example, when it can also have that an application got an unexpected exception and they want to rebuild the state, right? And just throw away the application, rebuild the application, rebuild the state. That is something you can have with CQRS, is that you have like a build and destroy mechanism on, for example, on your CI/CD. If I do a new upgrade or I have failure, I rebuild the whole state. But keeping like the logs forever, right? It sounds a great idea to replay them all, but we've seen the problem maybe with storage, and that's something that happens with Kafka. So Pulsar introduces tiered storage, and with tiered storage you can automatically push old messages for infinitive time to a cheap cloud storage. And you can retrieve the messages just like those that's coming in from the event stream. So like from the fresh messages, because they use the same API. So when a new consumer is there, it uses the API, and then also the broker and the bookkeeper knows like which segments and which things, which index is already in a cheap cloud storage, and then when you do when you start up, it will pick up all the data from the cloud storage and then processes new fresh messages. But for the consumer, the client, they use the same unified API. So this is a Pulsar log, and when it gets too long, for example, I have 5 segments here, 0 and 1 are already maybe 2 weeks old, or you do daily or whatever, what you want. You can offload it to either Amazon S3, Google Cloud Storage, or to a file system. So maybe a shared file storage somewhere that you have. Let's see some questions. Difference between log and ledger. Ledger, they always mentioned in account. Ledger, they always mentioned in account. Between log and ledger. I don't know, always mentioned in account. I don't know what you mean with that. But the log is one append only thing. It's a big thing. If you want to, like, it get bigger and bigger and bigger. Like a ledger is also append only, but it's divided in blocks. It's divided in segments, so you can copy over that specific things. And that's also how distributed networks. That's how peer-to-peer works. That is how BitTorrent works. It's in that different. So with TID storage, what I already mentioned, so new tenants, like they use bookkeepers, they can easily sync the data from this TID storage before they start, and then consumers can easily already get them from the same API. Number 4, stateful versus, let me check the time. Okay, stateful brokers. So every broker contains the complete log for each of its partitions. So when Kafka, a broker fails, it won't work. The work usually can't be taken over by just any broker. It can only be taken by a broker that already was synced up completely before the first one started to fail. And yeah, even when the load is getting high, it's like it can be the synchronizes. It needs to synchronize the state from other brokers that contain the replicas and its partitions. If there's a broker that doesn't have that, because you just have 2 brokers and you didn't calculate the high availability, needs always be n+1. So it's always 3, 5, 7, 9. It needs to be always an uneven number. Then you can get problems there. So with Pulsar, it's stateless. So this means that the broker doesn't hold state. Pulsar holds state, but not in the broker itself. And so what the broker does, it only accepts data and it sends data. So from producers to consumers, and the data is separated in Bookkeeper. So if the load gets too high, in this case, then you can easily add a new broker, because a broker doesn't hold the data. So the broker is like you have a load balancer and you say, okay, go to this gateway or go to this gateway or go to this broker and this broker. Without any data that needs to be loaded, because the fresh messages will go over the broker. The only way is that you have a new consumer and you want to be able to have that for to get all the data. Then the broker will evenly connect you to an so you can because the data is stored in a Bookkeeper and not in a broker. You can just do the load and have a new broker. and in this case, bookkeepers can also be scaled separately from the brokers. Yeah. So this is a plus for event sourcing and CQRS because data is always delivered in real time to the consumer. Even if the load is so high, you can just add another broker. So this is a little bit the architecture of Pulsar. You see here that a producer and a consumer connect to a dispatcher, a zookeeper in this case, global dispatcher, which include the load balancer. It concludes that this is the Pulsar, the broker. The broker has a dispatcher to receive and send the messages. It does the load balancer. So if there are multiple brokers, it registers itself to a service registry so they can find each other. They have the manager ledger and also a bit about a cache. So if certain things are requested, right, you don't have to go to Zookeeper first to the persistence layer. It's part of a cache in the broker. And looking at the time. A nice other one is the schema registry and message validation. So for CQRS, it's important that if clients only send known commands and not commands that can't be handled or cannot be understand. So commands, it's in this case, it's nice that you can validate the commands. So Kafka, you can do that, but only with Avro schemas. And to be able to do that, you also need to build a little bit of programmatic code to encode and decode this Avro schema. In Pulsar, it's a little bit different. They use type safely in any communication between producer and the consumer. For the safety in messages to know what you send over, and it's a little bit about the rules. In blockchain, you have smart contracts and smart objects, or smart contracts with functions that validate rules and information that's stored in the ledger. This is the validation part. So you can do that client and server side when you put a message on the topic, and when you read the topic, you can validate if the message is in the correct way you want it to have it. So how it works is that Pulsar, you can make a Pulsar schema and you can apply it on the topic level. And then this can be done by producers, and consumers can upload these schemas when they want, or when to have that and ask that. Okay, this is the way that I want to receive the message. And the schema is where if you create something, it's JSON, uses JSON format, where you just have a name, you have a type, a schema, where it's called is the binary representation of it, and then you can have user-defined properties in a string, in a key value map. Pulsar understands next to Avro, like Kafka, it also supports JSON schema. So that's, I think, the most easy one to implement. PhotoBuff is from Google, protocol buffers. That is something where you can also find a lot of standards. Maybe if you have like a company-wide standards, you can find in PhotoBuff, you can find like already like a nice schema repository. Does it support gRPC? We will go over like the connection. I don't know this specifically. It's built also on Zookeeper, like, and so like I think maybe it's part of Zookeeper, that one of the dispatcher, like in Kafka. So that means probably, I can't say that 100% if it supports gRPC. Yeah, it's a good thing to search for. I don't know, probably. Yeah, and it also supports strings and raw bytes. And a string, you can do like a certain pattern. You can give up a pattern, and then it needs to be like in a certain pattern. Yeah, the information needs to be, it can be validated with that. Or if you don't have a schema, it's the raw bytes that go over. Yeah, I already said, this is the last one really I want to go over in detail and then show you how it looks like what I did on OCI. For event sourcing, you have like, it's sometimes needed to perform computations before a message goes to the consumer. So Kafka supports event streaming. It's a Kafka streams you have, but you can say, I want to like be able to have this kind of amount of messages, and I do maybe some message transformations, or I do some, you can do some alerting. And if you want to do real processing on information, then, and you need to already maybe go to Apache Storm or Apache Spark. What Pulsar, with Pulsar you can write functions, and what I said in Java and Python, and you can deploy them to a cluster, and without needing to run any separate stream processing engine. So functions are lightweight compute processes, and they are executed each time a message is published on a input topic. That's the simplest ways, but let's go a step further. So I already mentioned that they are executed each time a message is published on a topic. This image you see, I have multiple topics, and a function can be like attached to one or multiple topics. So if you want to reuse a function, this function, what it does is it has some processing logic that you program in this function, and then you can publish the message to one or multiple topics. So a plus for event sourcing and CQRS is that we have some common processing logic on an event message for all tenancies or everybody that's on this topic, right? So we build a function that does something on the information in an event without redundant programming by like your client application. So this function can also be then transforming messages or do things so that like your view application needs to have a different message model than like the command that's coming in. And they can be written in two ways, or you can be written in Java and Python in two ways. Or you use the language native interface. So within Java, you have a functions class, but it doesn't require any Pulsar specific library. So you can make a generic application that can receive, or that you can make a generic function without any dependencies or anything. So you can also just test it locally without any Pulsar specific libraries. And the other one is that you have the Pulsar Functions SDK, and they leverage Pulsar specific libraries. And that gives you a lot more flexibility and functionality than just the native function where you just get the data in. And one of the things is state management. And for that, it uses the context object within Pulsar. So this means is that not only you can look at the message that's coming in, you also can look at the current state. So if we go back to blockchain and smart contracts, it's like I have a smart contract that says me these kind of policies I want to check. If this message comes in and it is maybe a change event, is it possible to do this change event on the current context of the data? This is not possible with the language native interface. Yeah, another one is consumer. You have like the mechanism between consumer groups and subscriptions. Kafka works with consumer groups. So if you want to have like separation between like maybe some not replication but distribution over like now I have this application with consumers and maybe another a duplicate one. With Kafka, you can you can have them read by certain consumer groups. I just if I distribute the slides or something like that, or this is something interesting, I will go over a little bit because there's a quiz question about this. There are a few subscriptions available, subscriptions mode available in Pulsar, which you can put on a topic, which is exclusive read, exclusive shared and failover. So Apache, the exclusive means that multiple producers put messages on a topic and partitions. And in the subscription, you say exclusive. That means that only one consumer can read this message. If one consumer reads the message, there will be an acknowledge, and then the message will be not readable by the second one. So this is the first come, first serve one mechanism, because maybe it's just you just want to distribute the load. Then you have like the shared mechanism, where you have like that multiple consumers can read this message. And if, for example, consumer 0 and 1 doesn't read it, then consumer 2 can, for example, read it to a failover subscription. A failover subscription is if you expect that consumer 1 reads the message, but if it doesn't, then consumer 2 can take it over. So maybe you have like your main application and your standby application. You can also set with these things, so who can read the message, how many consumers can read it, not only that that if you share it, everybody who can read it. Now you can even set an amount of consumers to read the message. And if all consumers read the message, then, and you have a lot of acknowledgements, it's okay, then the message will be, it will be put in a cold storage or put persisted, so it's not read anymore. Some other reasons that I already went to. 2 other things: retention time. So Kafka uses retention time and it deletes message based on retention. So even if there's no consumer and the retention period is ended, the data is lost. And with Pulsar, only the messages are deleted when all the subscribers based on the subscription consume the messages, so you don't lose the data here, even if consumers are down for a long time. You can still configure a retention time, and it can even be bigger than people consume them. So if you send them retention time, it's mostly because you want to keep it just longer than it's consumed. And Kafka doesn't support any time to live. So that means is that if I send a message on it, then maybe this message is so important and so maybe for security reasons that you can only process it within the first 4 hours. After 4 hours, if the consumer doesn't have picked it up or go online, then this message is not available anymore for this consumer. So you can do a little bit with that for a little bit of security stuff. It's now 11:30. For the quiz, we need a little, maybe, I don't know how much time we need for the quiz normally. I think maybe 50 minutes.
Robert, yeah, so we need 5 to 10 minutes, but if it's already done, maybe you can take a few questions if anybody is, I think you answered most of the questions during the session.
Yeah, I just sent them in. If you have now questions, in the meantime, I can show you a little bit about what you can try yourself to get started. So I made on my GitHub, Robert van Mulken, you find a repository called Pulsar on OCI. You find 2 things, and in the future it will be more, is how you set up the environment and how you can get started. So the setup procedure goes over the way how to provision in the future, how you need to provision like a Kubernetes cluster on OCI. And I see that I'm already logged out. So if you are on any region, it doesn't make everywhere it's available. If it's a Gen 2 data center, and you can go to developer services, and then you have container clusters. And in container clusters, you find you can create a cluster. And when you create a cluster, just use quick create. You don't have any knowledge about what's done. If you want to do it, you can do a custom create, but just launch the workflow, pick a name, use the version of Kubernetes you want to use. I suggest always use 15.7 in this case. What you want, how many nodes you want, and also if you want to enable the Kubernetes dashboard, I would say, yeah, for development or any prototyping, enable it. It's useful. So once it's created, you can get all the information, how to access your cluster, how to do the configuration and these like that, installing also OCI. But in the setup, I have some things there, like what to run. And the most things here is that you configure also Pulsar, you install it through Helm on the container cluster. You need to install some things on the cluster for also certification management if you want HTTPS. And you can do the preparation and installation of Pulsar using a specific thing. This will be, I will add some things in the future. So once you're done, and this thing is what is there, is that you can ask on Kubernetes where it's running. It's the important thing is to know like the IP address where something is running on. Because if you communicate to the things and you want to build something in Java, or you want to just test something out on command line, you need to have like some information. For now, I do this to get to the certain two consoles. And the first one is Pulsar gives you also an admin console, and it gives you a Grafana UI. And if you follow my instructions, it's just the default username and password. What you can do here is, this is the service URL. What you normally would do, you create a new environment. One. And then you can go to this cluster. And then you see information about my cluster, where it's running on, what's the URL, which brokers there are, which bookies there are. Here you can manage your, everything, your whole configuration of your cluster. You can create and view tenants. So I created a tenant for the use group. And these things are not done by the UI, by the way. So in the demo, GitHub, nou, eens even kijken. Yeah. If you go to my getting started, you you can get the list of, let's do this. You can get all the list of the clusters, the same thing you see in the portal, and create a new tenant, and create you can create roles or not. I'm not go into that yet, but you create a tenant. You can get all the information. You can get started with creating a namespace. So namespace is something where you say, okay, maybe an application name, something like that. Okay, this is all the topics that are now under this namespace are related to this application, or are related to this department, or are related to this, mostly maybe on a solution way. So in this case, for example, I already created the tenant and everything. So if you log in, if you set up Kubernetes, you can log in to your Pulsar environment. I see, for example, here I ask for the namespaces. There's one namespace. You can create topics on this. So let's create a topic with a maybe with a different name. Maybe we say it's events. And with this command, what I show you what you can do is you set up the amount of partitions. So every partition can handle 1.8 million messages per second. So with partitions, it also costs storage, of course, but it generates the correct partitions on the cluster. And this, if I do this now, you will see that immediately back in the admin. So if I go to my tenant, I have my namespace, and I see directly that I have 2 topics. You can really click through this. There's a lot of information, a lot of performance things that you can see. But here you see it's created. I have an events topic. And on this events topic, let me check the time. I will create a 2 things. I'm gonna create a consumer. You can do the command line, and this is something you can program in. Of course, with an application, you will program this in. This is just the CLI way to get information. Maybe if you have an edge device within IoT, you can use this to read messages back. I would still prefer to build it then maybe in Python, or to use the things the way to create your own client and server applications. But this is just for getting started, right? If you want to do it, just get started. So I can, in this case, create a consumer. And it's not for the metrics one. I created a metrics one, but for events. Yeah. And then so you create a consumer that starts to wait on this. On this topic, and hopefully I'm on time before timeouts. So if it doesn't get any messages within a certain time, this client, the CLI, will eventually time out. Yeah, that is what I see. Okay. So I connect again to a specific pod, and that's the Pulsar Mini toolset. Or if you call your cluster something else, it will be cluster name toolset. And then I take the same message, but let's read from, or let's publish something on this klus on this topic. And we got a message. So I skipped from the producer, right? It has one message successfully produced, and then on the consumer you see it's got a message, but it's still active. So yeah, I close it. You can also remove partition topics, but only if there's no active consumer. And you can also get some statistics. This can be done by the command line, but the most interesting thing, and I will conclude my demo with this, is that one, you have a Pulsar admin. This is good for any DevOps kind of way, or for the operations, where you can see the messages coming in, you can see the subscriptions, you can see, I can click on, for example, a partition. If there's a consumer, I can see the consumer. So for example, if I start again, hopefully there's a command. Yeah, it starts again. And I go and refresh everything. Then I see there's a new consumer, and on which port it runs, on which IP it runs. So this is where you can also see, is my IT device connected, for example. In management, you can also define policies. Everything you can do with management on these things, on these kind of things, you can do that also with the UI. Other thing, what I now conclude my demo with, is there's another thing, it's the Grafana dashboard, which is out of the box. It's something with if you do Kafka, you need to set up this yourself all. I have some dashboards where I can, for example, see how many messages are coming, how many topics I have, how many producers I have, which kind of namespaces I have, what kind of load is there, what kind of storage I have, if it's replicated or not. Now, for this case, it's not, so it's not an interesting one. You can also see metrics on the bookie. So how is my performance of my ledger? How with the server, the amount of bytes that is sent, how does my storage handle everything? So this is interesting that it comes out of the box with Grafana. And also you can check specific also stats on how long it's uptime, what is used, and all these Prometheus kind of statistics. So yeah, so if you get started, you can follow already my GitHub stuff. This presentation will also continue and get bigger, and mostly on the hands-on side, because try to plan some, besides the presentation, only hands-on side. So that's something to keep in mind, that it will be bigger and bigger. But it already helps you to get started with these basic things. So with that, I conclude my presentation, and I think again hand it over back for the quiz.
Thank you, Robert, for your time and support. We really enjoyed your sessions. So as suggested earlier, please use hashtags, and Robert Twitter ID is here. I think let me move this one a little bit down, so that way you can connect. And if you have any questions, again, it's up to Robert to respond, but that's a Twitter ID
to respond. So
yeah, okay. And important thing is we will send you a speaker survey today or tomorrow for all registered participants. So request you to spend a few minutes to complete the survey, and then you are able to access the presentation in the same survey link. We are also happy to issue a certification of participation. If you attend all the webinars in the month, reach out to webinar.aavg.org. So we have already received a couple of them. We will definitely respond as soon as possible. Now the exam time. So let's go to the exam now. Let's test your knowledge. I'm sure you guys know what to do with the exam. So basically, oh, one second. Yeah, basically join the menti.com. The code, today's code is 888284. Looks like a lucky code. Please join this menti.com, and we will run through 5 questions, and we'll test your knowledge, and winner will so if you are new to this quiz, so basically, there are 5 questions in this quiz. You need to answer as soon as possible. It's not the right answer. It's the quickest answer, right? So that's very important. So please answer as soon as possible, and basing on the timings, you'll get points. Okay, I'll get started. Start the quiz. Yeah, this question have a multiple answers. So if you're selected only one, maybe that's why you're not win. But let's see who's in the leaders board. So fastest was Sharad. Let's go to the next question. Only 4 people answered the right question, right answer. Let's see who's in leaders board. Priyank actually answered the fastest, but yeah, so all the best for next question, Priyank. And still Sharad is actually leading the board. The next question. This is the right one. I think someone asked what is a bookkeeper. Thank you. Let's see in leaderboard results. So Prakash is coming top, and Hari actually answered the fastest. I think this is going to be the last question. Let's see. Oh, we have one more question, by the way. Good. But nobody answered nobody picked the last one of the answer. Leaderboard. Prakash, again, Hari tried really best, but you missed one answer. I think this is the last question. So Let's see who's going to win this. Okay. Congratulations, Prakash. You are the winner for the today. So we'll reach out to you for a gift voucher. And next topic, who's coming next week? I'm not able to move this one, but anyway. So next week, webinar from Lucas Jalelama. He's also Groundbreaker Ambassador, Oracle is Director, and he's also CTO of EMIS, where actually Robert works. And he's going to talk about cloud native application development. Um, he's going to talk about a lot of technologies inside, and he's going to use OCI, Terraforms, and Oracle Cloud Infrastructure. So please join next week. That actually concludes this month. This is like last webinar of the month. But the next bigger thing is about I'm sure most of you know. Um, After going through a lot of efforts, some of my team members are going through sleepless nights. We are going to open Oracle Groundbreaker Yatra 2020 registrations very soon. Just watch out two websites, ogyatra.in as well as aioeg.org. And you can see that, statistics. I think this is one of the bigger one compared to entire world, what we are doing currently, the tour. Like it's a 16 days. If you exclude the Sundays, it's like a 14 days, 8 sessions per day, or 100 plus sessions, 50 plus Oracle community, 25 plus Oracle speakers, 25 countries. Um, you know, when we are actually putting everything in a schedule, and we can see the depth and of the technology we are covering. So please join this one without any fail. Even if you want to apply leave in your company, you do it right now, because this is going to uh, you know um, cover pretty much everything in Oracle and non-Oracle space. Okay, so these are the two websites, ogyatra.in as well as aiog.org. So we are in process of uploading all the speakers, sessions, everything. So we will open today or tomorrow. So one thing is, every time we do, a minimum of 500 rupees charges, but since it's online, it's a free to attend. But again, it's a first come first serve. We have a limited number of capacity in Zoom, so we will allow only limited numbers. So it's very important to join and register. First of all, register and join, and we will, give you a step-by-step registration process. And we are also going to announce many more things next week in terms of what benefits you're going to get, and we'll walk you through the entire process. So with this, we will end today's webinar. Thanks, Robert, for your time and support. And I'm sure we will catch you again for another presentation. And bye for now. Thank you. Bye.
Thank you. Bye.